Hi everyone, today we're going to take a look at some trig review. So this was chapters 7 and 8 in grade 10, and we're just going to do this as a trig of right angles and non-right angles review to get us prepped for our grade 11 work. So the first thing that we learned about trigonometry in grade 10 was SOH CAH TOA. And SOH CAH TOA stands for sine, cosine, and tangent, and uses the sides opposite, adjacent, and hypotenuse to set up ratios between the sides of a right angle triangle. So just to remind you, as far as labeling the sides, opposite, we're going to locate whatever our reference angle is. So it will either be indicated with a theta, or the question will tell us what our reference is. Across from our reference angle will be the opposite. Across from the right angle is hypotenuse, and the remaining side that touches the theta that is not hypotenuse is adjacent. So those are our three sides. Sine, cosine, and tan. So firstly, we have SOH from SOH CAH TOA. This stands for the sine of our reference angle is equal to the opposite side over the hypotenuse. Then we have CAH, which represents cosine of theta, and that's equal to the adjacent side over the hypotenuse. And finally, we have TOA, which represents tan of theta, and that is equal to the opposite side over the adjacent. So SOH CAH TOA, it's important that we remember, can only be used with right angle triangles. This is not a valid relationship when we're working with non-right angle triangles. Also, if we're trying to find, let's say, all three sides of a triangle, or we have two sides and we want to find the third, we can always use a squared plus b squared equals c squared to help us find an additional side. So this is Pythagorean theorem, and this is also only valid when we're working with right angle triangles. The other things that we learned in grade 10 are sine law and cosine law, and these are for what we call acute triangles or non-right triangles. Oops. Okay, and there's a couple scenarios where we would use sine law and cosine law. So firstly, of course, we have to have a non-right triangle. And we can use sine law to find an unknown side if two angles and a side are known. Or we can use sine law to find an unknown angle if we know two sides and an opposite angle. For both scenarios of using sine law, we always have to know a side and its opposite angle pairing. Otherwise, I always go to cosine law. So do I have a side and do I know its opposite angle? Or can I find its opposite angle by subtracting the other two angles from 180? If the answer is yes, you go for sine law. If the answer is no, you'll probably have one of these two scenarios where you'll use cosine law. So we can find a missing side of an acute triangle if the two other sides are known with a contained angle, and essentially this just means that the angle is bordered by the two sides we know. Then I would be using this formula, and we can also rearrange this formula to find an angle. For the first one we would be using this formula, and then we can rearrange this to find an angle if three sides are known. So I would be using this. Okay, so let's just use that information above to take a look at these different options and decide whether we would use sine law or cosine law. We're not going to solve. We have a couple examples later that we'll use to solve. So I want you to take a second. We're going to pause, and I want you to see if you can decide whether you should use sine law or cosine law. So now that you've taken a second to do this, we are going to take it up. So here I know two sides and I want to find, I know two angles and I know a side. I have this side and opposite angle pairing, so automatically when we have that pairing, we should be using sine law. Okay, in this case, I don't know a side with its opposite angle, so I actually have the scenario here where I have two sides and what we call a contained angle, which is in between those two sides. So this one would be cosine law. Okay, this one here, I know all three sides. I don't know a side and its opposite angle, so I would be using cosine law. And finally, for this last one, we have, again, that side and opposite angle pairing. So as soon as I see that, we can say sine law for this one. Okay, so let's take a look at a couple examples. So we're going to be mixing in right angle triangles and non-right triangles. So just remember that if I see a right angle indicated, I'm going to make sure that I'm just using SOH CAH TOA and Pythagorean theorem. So in this case, we're given an angle. That's going to be our reference angle, and I'm going to label the sides based on that angle. So we have a side labeled x, and that's what we're going to find. This is opposite to the angle that we know, so we're going to call this the opposite side. And then the 30 meters is opposite to the right angle, so this must be hypotenuse. So I would always be asking myself, when I'm looking at SOH CAH TOA, which trig ratio uses the sides opposite and hypotenuse. So if you said sine here, you would be correct. So we're going to say sine of theta should be equal to the opposite side over the hypotenuse. So sine of our reference angle, which is 41, is equal to x over 30. And to get x by itself, we're simply going to multiply up 30, and these will cancel over here. So we've got x equals, and I always put the 30 in front of the trig ratio because we don't want to accidentally do the sine of 41 times 30. We want to do the sine of 41 and that whole answer times 30. So if you look at your calculator, the first thing that you just have to make sure of is that you're in degree mode. So if you look at the window on your calculator where you type in your numbers, you should see either like a highlighted D or you might see DEG. That's what we want to be in for this trig. So make sure that you're in that mode. If you're not sure how to switch your mode over, look at the number on the top of your calculator and you can type that into Google and type in like how to switch from degree, radian, and from degree to radian mode or radian mode to degree mode. Okay, so that's important that we're always in degree mode for this unit. And we're going to type in 30 sine of 41. And let's round to the nearest hundredth here. We should get 19.68 meters. Okay, next one. I have a reference angle here. I know that reference angle is opposite side, and I know the additional side that touches my angle, that's not the hypotenuse, so this must be the adjacent side. So again, if we look back at SOH CAH TOA here, I want to choose the trig ratio that uses opposite and adjacent. So I'm going to choose tan TOA. So the tan of theta is equal to opposite over adjacent. And then we'll type in the sides here, so 3 over 7. Now this is a little bit different than the one that we did above, because the one that we did above, we knew the angle. This time we don't know the angle, but we know the two side measurements. So we have to remember back from grade 10 how we separate out tan and theta. Because once I have tan and theta, those two things can't really be separated. Just like if I have a square root, let's say I have a square root of 9, I don't move either of those two things individually. That sort of has to move together. Or really the square root doesn't mean anything unless it has a number underneath. And that's the same for a trig ratio. If I just had tan equals 3 over 7, this actually doesn't make sense because tan needs something plugged in inside of it, like an angle, in order for that function to actually work. So the only way that I can take these apart so that I can isolate for theta, just like if I were trying to isolate for, let's say, an x underneath the square root, is to do the opposite function. So if my x was under a square root and I squared it, then these will cancel out and I'm left with x. And I'll do the same thing, of course, if I have another side of the equation. The opposite to tan is what we call tan inverse. So if you look at your sine, cosine, and tan buttons, you might remember from last year that we pressed our second button on our calculator, or for some of you it's shift. And that will allow us to get to these little inverse functions on top of our buttons. So you'll see these 3 buttons, and these are what helps us isolate for an angle. So in this case, we'll use tan inverse because we had tan. And if I take the tan inverse of each side, which is technically what I'm doing when I do my inverse function, then these will cancel, just like a squared and square root cancel. And I'll be left with theta equals the tan inverse of 3/7. So we're going to type that into our calculator. Make sure you open up a bracket when you do the 3 divided by 7 or the 3/7, and then close your bracket afterwards. If you've done it right, let's round to the nearest tenth here. You should get 23.198. So that's going to round to 23.2 degrees. Okay, I don't really need to see this part here. I'm just kind of showing you that's actually what we're doing, is taking the tan inverse of tan to separate the tan and the theta. Okay, here I'm seeing some non-right triangles, so we're going to be using the laws for these ones. So the question always is, if I'm deciding between sine law and cosine law, is do I have a side and its opposite angle? And in this case, I do. And this is our other pairing here. And I usually use sine law interchangeably in the sense that if I'm looking for a side, I will use it with the sides on top. But if I'm looking for an angle, I will flip all of these upside down. And that just makes it a little bit easier to isolate. So in this case, I'm looking for a side. So I'm going to say P over the sine of capital P is equal to lowercase r over the sine of capital R. And I also just want to remind you guys back from our trig in grade 10 that we label the sides of a triangle with the lowercase letters that are across from their opposite angles, and the angles are labeled with uppercase letters. So let's plug in what we know. 8 over the sine of 68 degrees is equal to r over the sine of 57 degrees. And in order to get r by itself, we're simply going to multiply up the sine of 57 degrees. So these will cancel. And make sure that you're following along with your calculator here. We're going to type in the sine of 8 times the sine of 57. I would press equal on your calculator and then divide that by the sine of 68. So r is going to be equal to let's say we'll round to the nearest hundredth, 7.24 centimeters. Okay, going along to our next example here, do we have a side and angle an opposite angle pairing? The answer for this one would be no, so we need to use cosine law. And my cosine law always starts with the side that you're looking for. So it will be d squared, and then the other two sides, so this is side little e and side little f, so it will be the other two sides added and squared, subtracted by 2 times the other two sides, e and f, times the cosine of that is opposite to the side that you're looking for. So cosine of d. So if I'm looking for d, those will always match. And then everything else, e and f, will be the opposite, the other two sides. So let's plug in what we know here. Okay, if I've used this formula correctly, and I've chosen the correct formula, I should have everything filled out on this side. If you don't have everything filled out, you've either selected the wrong variables here, or you've selected the wrong equation to work with. Okay, so if you want, we can sort of do this piece by piece. I'm going to do this first. This should be 317. And then, you know what, actually, yeah, that's fine. So we'll do 317, and then I'm going to do 2 times 11 times 14, which will be 308 times the cos of 82. And then we're going to do this all together. Please remember to follow BEDMAS here. I am not subtracting these first. Okay, I see people do this a lot. This is multiplication, and this part actually has to happen first. If I were to enter all of this into my calculator, it actually takes care of bed mass for me. Or if you want to just be safe, you can always enter this part in brackets in your calculator, just to make sure that it doesn't do 317 minus 308 first, but it shouldn't. So we should get 274.1346849, and notice that I'm keeping all the decimals here. I'm actually leaving this right in my calculator because this is a repeating decimal, and I'm going to square root each side to get d squared by itself. So I just want d here. So this should be 16.56 centimeters. Okay, let's take a look at a couple more here. So again, dealing with a non-right triangle here, this has all three sides, so I don't have a side in its opposite angle pairing. That tells me I need to use cosine law. And for cosine law, this is the law that's rearranged, or the formula that's rearranged to be isolated for an angle. So I'm going to start with cos of A. And the formula can look like this, or you can have it as a squared minus b squared minus c squared over negative 2bc. This works as well. The important thing to remember is that if I'm looking for cos of A, the last piece here should always be A, and the rest of the pieces are the other two sides that I know. So in this case, this will be b squared plus c squared minus a squared over 2bc. And I'm going to just label the sides here with their lowercase letters. This is 10 squared plus 11 squared minus 9 squared, all over, I'm going to say cos of A there, all over 2bc, so 2 times 10 times 11. And what might be helpful for you is just to evaluate the top and bottom separately. So I'm going to do 10 squared plus 11 squared minus 9 squared. I'm going to get 140. And then I'm going to do 2 times 10 times 11, and I'm going to get 220. In order to isolate for A, I'm going to do what we talked about above, which is to take the cos inverse of each side. And so I'll be left with A equals the cos inverse of 140 over 220. And let's round to the nearest tenth here. So cos inverse, make sure you use that shift button or second button, open up a bracket, and do 140 divided by 220. Close up that bracket. And rounding to the nearest tenth here, it should be 50.4788, so 50.5 degrees. Okay, and then the last one gives us the information. We have to fill it in. So side V, I know that because it's lowercase, is 11.1 centimeters, and I know this is side V because it's across from angle V. Side T, across from angle T, is 5.8 centimeters, and angle T is 31 degrees. Find the measure of angle V. So this is the question mark here. So if I'm looking, I'm noticing that I have this pairing between a side and its opposite angle. And I have the opposite side to V, or opposite, yeah, the side that's opposite to angle V. Because I'm looking for an angle here, instead of doing the sides on top, I'm going to do the angles on top. So I'm going to do sine t over t is equal to sine v over v. This is essentially like, I can say 1/2 equals 1/2, but it's also true to say 2 over 1 equals 2 over 1 as long as I flip both of the sides. So that's basically what I'm doing with our formula. So sine of t, 31 degrees, over side t, 5.8, equals sine v over side v, which is 11.1. The reason why I flipped the formula is because now all I have to do is multiply up 11.1, and then I will have the answer for what sine v should be equal to. I'm going to calculate this all together in my calculator, So I'm going to do 11.1 times the sine of 31. I'm going to press equals in my calculator, and then I'm going to divide that answer by 5.8. If you've gotten this correct, it should be 0.985676315. I'm leaving all the decimals here, and I shouldn't even have to worry about this, honestly, because I'm leaving this in my calculator, and then I'm just going to take the sine inverse of that number right in my calculator. So I shouldn't have to type it in again to my calculator or anything like that. So we're going to take the sine inverse of the answer here. So if you don't use your answer button, you should start to get familiar with that. Sine inverse, and then I hit my answer button, and then I got 80.3 degrees.